the network is sometimes unstable, emails can still be reliably transmitted. However, teleconferencing is occasionally suddenly interrupted. Carrier B provides reliable network services at higher costs. Is it possible to take full advantage of Carrier A and Carrier B's networks by freely switching between the two? Of course it is. Policy-based routing can forward packets and select paths based on predefined policies. The problem is that PBR policies are difficult to define because the link quality is constantly changing. There is no need to worry about this, as smart policy routing is able to solve this problem. SPR actively detects the link quality and matches service requirements to select an optimal link for forwarding service data. Subsequently, services are transmitted normally at a reduced cost. How is SPR implemented? Imagine that the email server IP address is 192.168.1.2 and the call conference server IP address is 192.168.1.3. You can configure ACL policies to differentiate service packets based on destination IP addresses of packets. During email transmission, people often focus on whether packets will be lost. During telephone conferences, people often focus on the link delay, jitter, packet loss ratio, and composite measure indicator. You can create probes for the links that transmit the two types of services. The probes are also called network quality analysis test instances. If an NQA test instance for a service link fails, it means the link has not met service requirements. In this case, you need to configure other available links to ensure service transmission. Provision email services. You can configure Carrier A's network as the primary link and Carrier B's network as the backup link. To provision telephone conference services, you can configure Carrier B's network as the primary link and Carrier A's network as the backup link. When the primary link does not meet service requirements, services are automatically switched to the backup link. When the primary link recovers from a fault, services are automatically switched back to the primary link. Best effort link is rarely used. A best effort link is used only when both primary link and backup link do not meet network service requirements, which rarely occurs. Generally, it is unnecessary to configure a best effort link. Link switching time, also called switching period, is configurable. In the switching period, if the network quality does not meet service requirements, link switching is triggered. Generally, a shorter link switching period makes services more stable, but it may also cause frequent network switching. The default switching period is 60 seconds, which meets the basic service requirements. The live network has more applications and complex links, so the link group mode is more flexible for link selection. Voice services require a low delay, low jitter, and low packet loss ratio. IPTV services are live and provisioned in real time, requiring continuity and high throughput. Voice-on-demand services do not require real-time transmission and can cope with delay and buffering. These packets can be classified based on the QoS DSCP value proposed by the IETF. Different NQA test instances can be created for these packets according to their classification to determine whether transmission links meet service requirements. You can add the preferred link connecting to the voice server, preferred link connecting to the IPTV server, and preferred link connecting to the VOD server into a link group and set it as the primary link group. Similarly, set the backup link group, apply SPR to ensure service continuity. At last, let's review the SPR configuration procedure. Configure an ACL to differentiate services. Configure NQA test instances according to service requirements. Configure the primary and backup link groups according to service configurations, and then configure link switching parameters. These parameters are optional. Reminder, the SPR function requires a license, value added service package.